Hello, welcome to this video that goes through some completing the square questions. So first question is question 7, f of x equals 2x squared plus 3x minus 2. Solve the equation f of x equals 0. So there's several ways of approaching this question. So essentially we just say 0 is equal to 2x squared plus 3x minus 2. At this stage, because it's an A-level question, you have the calculator that you can use to find it. So just using a scientific calculator, you can put the quadratic in here. So if you just press menu, then equation and function, polynomial, 2 degree, and then you can just plug your answer in. So 2, 3, and minus 2. That gives you your x values, which is x equals 0.5 and x is minus 2. Again, so this is when y equals 0 essentially. But that is the solution to this question for part A. You don't need to do anything. You don't need to show anything until that one. You can just put the answer, and that's what they expect you to do. So that will be the first step I would do for solving the equation. The other solution to do this one is you can try and factorize it. Alternatively, you could look at completing the square as well. The next one is sketch the curve of the equation y equals f of x, showing the coordinates of any point of intersection with the coordinate axes. So if you know that x is 0.5 and minus 2, then we know that that's when y equals 0. So we know that when we sketch our axes, we know that it's going to cross the x-axis at minus 2 and at 0.5. We also need to find where it crosses the y-axis. So to do that, we plug in x equals 0. So that is going to be f of x, or y, is equal to 2 times 0 squared plus 3 times 0 minus 2. So f of x is equal to minus 2. And so therefore we can plug it in here. Minus 2, and then that will be our sketch. It doesn't ask us to find any turning points in this question, so we can go ahead and just sketch. Again, it's just a sketch, so we don't know. So as long as it's the U shape, that's perfectly fine. We've got to crossing the coordinate points, so it's all good. I'm just going to go back to part A, just in case the expectation is that you do need to solve it. So the way that I would approach this one is probably using the Wendy method. You can also use the quadratic formula. So quadratic formula is minus b plus or minus square root of b squared minus 4ac over 2a, but this is factorizable. So just a quick recap of that method. So the first thing we do is we do a times c. That's going to be 2 times minus 2, which is equal to minus 4. And then we look at the factors of minus 4. That can make plus 3. So we've got 4 and minus 1. And if we add those together, they make 3, which is b. So we replace b with 4x minus x, so we get 2x squared plus 4x minus x minus 2. And then we factorize the first two terms and the last two terms. So we end up with, take out a common factor of 2 and x to get x plus 2. And then we can take out a common factor of minus 1. So it's minus 1x plus 2. So end up with 2x minus 1, x plus 2 is equal to 0, f of x, so x is equal to a half, and x equal to minus 2. That's just in case the expectation is that you don't use your calculator. You can show that you've got the values that way. Question 8, express x squared minus 6x plus 11 in the form x plus a all squared plus b. So in this situation, we are going to complete the square. Remember that the general form of completing the square, when it's an x squared plus bx plus c, is equal to x plus b over 2 squared minus the bracket of b over 2 squared plus c. So in this case, b is equal to 6. So x squared minus 6x plus 11 is equal to x minus 3 squared minus 3 squared plus 11. That's going to be x minus 3 squared minus 9 plus 11. That's going to be x minus 3 squared plus 2. And that gives you your value, gives you completing the square. And then the next one is part B, sketch the curve y equals x squared minus 6x plus 11, show the coordinates of a turning point of the curve. So while it's not asked for any axes, I would probably show where it crosses the axes if possible. So x squared minus 6x plus 11. So again, when you're sketching this curve, you're finding the x-intercept, the y-intercept, and the turning point. So if you're finding the x-intercept, that is when y is equal to 0. So it's 0 equals x squared minus 6x plus 11. So for this one, I would, because it's just a sketching point, they're not looking for the details, so I would just plug this into your calculator. So again, menu, equations of polynomials, polynomial degree is 2, and then it's 1 minus 6 plus 11. So that gives you, and that shows you that there is no intersection with the axes, which you could have found directly from a turning point if you'd done that first. So there is no real intersects. The y-intercept is at plus 11, because when x equals 0, y is equal to 0 squared minus 0 plus 11, so y is 11. And then the turning point here, so we know that we can find it from completing the square. We change the x term, so it goes from minus 3 to 3, and the y term stays the same, it's 3 and 2. And from that 3 and 2, if that's the turning point, that is the minimum point, which means that it would never have reached the x-axis, and we'll show that through a sketch. So here we know that it crosses the curve at 11, and we know that at 3 on the x and 2 on the y, it's going to be a turning point, so it could be something like this. Again, it doesn't have to be super accurate, but you do need to make sure that you show the points clearly. And that is your answer for question 8. Question 6, given that the equation 4x squared minus kx plus k minus 3, where k is a constant, has real roots, show that k squared minus 16k plus 48 is greater than or equal to 0. So if it's got real roots, then we use the discriminant form, so b squared minus 48 has to be greater than or equal to 0, because that shows that it's got one real root, or two real roots, or because if it's greater than 0, it's two real roots. If it's equal to 0, it's one real root. From here, if we look at our equation, so our a is equal to 4, our b is equal to minus k, and our c is equal to k minus 3. So that's the a, the b is in terms of the x, and the c is the remaining terms. From there, we plug into our formula b squared minus 4ac. So b is replaced by minus k, so it's minus k squared minus 4 times k minus 3 is greater than or equal to 0. From here we expand, so minus k squared is k squared, minus 4 times 4 is minus 16, k minus 3 is greater than or equal to 0. So it's k squared minus 16k, and then 16 minus 16 times 3, which is equal to 48, was greater than or equal to 0. Then we solved for part A. For part B, find a set of possible values for k. So the first thing we need to do really is factorize this and find the values where it crosses. So again, this one you can just plug into the calculator, because your calculator can solve this. So we go to the polynomial function, and we say 1 minus 16 and 48. So we get, this is the same as k is equal to 12 and k is equal to 4. That is when, so for to do this one, we said that k squared minus 16k plus 48 equals 0, and then we solve that, so k equals 12 and 4. Now the next thing we should do is we should always sketch. Don't be overconfident here, just sketch it out. It means that you're guaranteeing yourself the answer, and it's worth the extra minute it takes to sketch. So here we've got 4, here we've got 12, and then we do our sketch here. And the reason why we do the sketch is because we're looking back to our inequality. Our inequality says greater than or equal to 0. Remember, this corresponds to the y. So here, any term that is less than minus 4 is going to be have a y value greater than 0. So therefore, we can say that k is less than or equal to 4. And then the second step is we've got any value greater than 12, so therefore k is greater than or equal to 12. And that gives you the set of possible values of k. Remember, you cannot put this under one inequality. It has to be two separate inequalities. For part C, state the smallest value of k for which the roots are equal and solve the equation when k takes its value. So for the roots to be equal, b squared minus 4ac has to equal 0. For that one here, we go back to our answer. So we originally said that k squared minus 16k plus 48 equals 0. Well, the results you got from here will give you the values where b squared minus 4ac is equal to 0. So here k is equal to 4, and if you wanted to test this, you can, because you can just plug in. So if we go back to our b squared minus 4ac in the original equation, it was 4 times 4, then k minus 3, so it's going to be minus 4 squared minus 4 times 4, 4 minus 3, which gives you 16 minus 16, which is 0. So that's, again, proof. We don't need to prove it, you can just take your answer straight away. So we know that k is equal to 4, and solve the equation when k takes its value. So here we say k is 4, so that's going to be 4x squared minus 4x, sorry, not k, minus 4x plus 4 minus 3 equals 0. So here it's going to be 4x squared minus 4x plus 1 is equal to 0. And then when we solve this equation, plug it into your calculator. So again, it's going to be 4x squared minus 4 plus 1 gives an answer of x is equal to a half, and that is it. That's going to be your only value. So x is equal to half. Again, that makes sense. There's only one value because b squared minus 4ac is equal to 0. So there's only one distinct real root. In this case, x is equal to 0.5. And that brings the end of these questions. If you have any further questions, please let me know.